Hello everyone, my name is Ahmet Saydın. Today I'm gonna present my Physics 211 project. My project is an acoustic levitator. Firstly, I want to mention what the acoustic levitator is. The acoustic levitator is literally levitate the small objects with the sound waves. These sound waves produced by transducers. Nearly 30 transducers, and these produces sound waves has an interference. That is why at some distances there is a nodes and antinodes, and sound is a mechanical wave, so it gives rise to differences in the density of air. So that is to say, because of the sound, the air pressure changes. It changes as a function of distance and time. But due to the interference, we eliminate the time parameter. So our equation just depends on a distance. That is to say, due to pressure differences, we have a force to eliminate the gravity. And then we have some particles which is smaller than which has having a diameter smaller than the wavelength, which is nearly 8 millimeter. Because particles should fit into these nodes. That is why particles diameter should be smaller than wavelength. So as the theory, additional for the theory, the particles also rotating. I will show why particles is rotating on the system. So let's in system, as you see, there is just one half sphere. So that is to say, we don't have any reflection surfaces. So basically, the force will also levitate, but it will also rotate due to the spherical, just half spherical shape of the transducers. So let me show you my circuit. Firstly, there is a jack which we power with 20 volts. And then there's a DC booster which gives rise to 25 volts, which takes 20 volts and gives 25 volts in DC motor driver. In principle, driving a motor or a transducer is the same thing. They are the same since they work with the signals. So we can use a motor driver here, and there is Arduino. We have already programmed to produce a signal and relay the signal through this cable to DC driver, and then to the transducers. Let me show you the levitation. As I mentioned before, the sound give rise to the pressure differences on air. So that is to say, maybe some systems can enable us to see this pressure differences, which is Schlieren setup. In principle, Schlieren setup is basically work with convex and concave mirrors. So in our design, in theory actually, in our design and theory, this principle is that when you emit a light from a point source to the convex mirror at the center of the mirror, then reflection return back to the this point source. So Schlieren setups work like this. We put a razor or some very thin obstacle to reflect the light, half of the re-reflected light. We do this because, as you know, if there is air is homogeneous, then light emitted by the point source reflected to the point source again. But if we put a razor at the immediate near of the point source, then if some air pressure or density changes, some light will be distorted, and they can go to the razor instead of light source. So that is why we can see in Schlieren setup the shadows of the movement. So in experiment, to test Schlieren setup, we first use fire to see the movement of air, and we achieve this. However, for the movement of air due to levitation could not achieved because of low FPGA of camera. And to mention this, in setup, we couldn't put the razor near of the light source because this isn't appropriate. So we put back to the point source. In this back, we can still focus the reflected lights at this point. So we set the camera and razor at this point, and razor adjusted so that half of the reflected lights cannot pass. So thanks for your listening.